So my name is Gluhak. I work for Intel Labs Europe. And I have the pleasure to give you a tutorial on one of, let's say, Intel's recent IoT platforms that are emerging, the Galileo. The tutorial itself will be done jointly with my colleagues, Jason Wright. Maybe Jason, can you get up quickly? So he's from Intel in the US. He's come over to spend 6 months with us in London, and he was given the opportunity to attend a summer school straight away. So, and then Michele Nati from the University of Surrey. I used to work with Michele before. I was also at the University of Surrey previously, and Michele kindly also agreed to help with the tutorial. So thanks, Michele. Okay, so I was also want to acknowledge basically some colleagues at Intel, from which I borrowed quite a few slides. So obviously the platform is out there since last year, and some people have been already doing some thinking about it. So I really want to acknowledge those as well. Obviously we added many other things that haven't been included here, but still some of the base content is from them. The goals themselves should be for you to learn more about the Galileos itself. So what are the Galileos, its hardware features, its software stack. Just maybe to ask into the room, who has heard about Intel Galileos before? 1, 2, 3, 4, 5, 6. Okay, a few people. So basically quite a lot of people here, they haven't heard of it. Okay, so also just maybe a question: who has some experience with Arduino? Yeah, a few more. Okay, good, excellent. So, I mean, I would also like, if possible, because this tutorial is kind of like really hands-on, and we will try to be doing things. If those who have a bit of experience as well try to help a bit in the tutorial, I would appreciate it very much. Okay. So the tutorial itself should provide some basic knowledge for you to become productive on this platform. So in one side, how to basically sense with it, how to communicate with the environment or with other platforms. And also you should be able to understand what are the different development options that are available to you on this platform. So it will be hands-on, so you will require to have a little bit of an, let's say, technology background. There will be a part maybe for business students that is interesting in the beginning, just to get a concept, but I think at some point maybe you may get lost a bit. So I will not be upset if you would not follow, let's say, the whole tutorial itself, because it's a bit technical. And so in the end, hopefully this tutorial will give you some set of skills that you can basically use throughout the summer school and come up with some amazing idea and present it at the end to us, like in your project work. And you get a chance as well to take basically, at least for the winners, the Galileos home. So the tutorial will cover 2 parts. One looks at the foundations, so it's roughly 90 minutes. So it's about just an overview, a bit of my background and the work I'm in, and then more about the Intel Galileo. Then connectivity basics, so how to kind of connect, interact with the Galileo and the environment, so networking aspects. And then looking as well at sensing, IO sensing and so on. And there will be part it looks more a little bit advanced topics, so once this basic set of skills, how to integrate, for instance, with existing IoT environments like Sively, like Parampo? And also this will be done by Michele. Then something about like the Node.js capabilities. So Jason will take you through this. So how you can easily run a web server on your Galileo and do things with it. And then something as well about Python, so you can also program in Python. So I will try to go through like some basics, also looking at some advanced network communication like using MQTT. So this should give you, let's say, a solid foundation, give you different flavors of how you can use the Galileo, and hopefully bring you into a position where you can do something interesting with it. So for logistics itself, so as I said, you will need some programming experience. Yeah. Just for me to understand as well, who has some programming experience? Yeah, it looks quite a lot. Okay, good. At least, okay. You will need a laptop. so I hope everyone's got a laptop somewhere with them. Not everyone actually, because we will work in pairs, so at least one of the two will need a laptop. The reason for that being is that we don't have Galileos for everyone, but I was able to bring 25 with me. I was also able to bring some sensing kits that you can easily use to interface with the Galileo, and then utilize those for a tutorial. So you will have to be sharing those throughout this. And I will later, as well with the help of Michele and Jason, distribute those in the room. Something that we also want to explain is like each Galileo has basically the ability to plug on different Arduino shields. What I have is basically growth base shields, so there will be a growth base shield for all of the nodes. But we don't have sensing kits for everyone, so you will have to share the sensors that are available in these 11 sensing kits. So, so I've tried to, at least in some of the tutorials, bring in different options where you can use, like, so maybe not, there will not be a button for everyone, but you have a touch sensor instead. So you can basically be a bit more creative, and I think it should be giving you enough still material to use. And these sensing kits as well in the Galileos, you can use them later throughout the week for your project work. Okay. So what you would need to do, obviously, is to have an Arduino development environment for it. So what I've done is, like, I brought a few memory sticks with me. I know internet may not be as quick. So I've got 3. I would want them to be kind of, now during the, let's say, first 40 minutes of the tutorial, if you could kind of copy down the files that you need. So there are 3 types of development environments for Windows, for Mac, and for Linux. So just choose the one that your laptop is. And the other files, so what I've put on it is some basic SFTP client, and as well I think some SSH client for Windows. If you don't have it, I think Mac as well as Linux will natively come most likely with it. Yeah. So these are files on it that you can pull down, and just choose the 4 ones that you need. And also there's a file which is a folder that has basically some examples for the growth sensing kit as well. So you can also copy this folder. Okay. So I will just pass them around now and just try to drag them over so we can basically, once we reach the stage of the tutorial, get started very quickly. Okay? Like one here, one here. Yeah, just pass it through. Okay. So maybe just a little bit of background as well about Intel, so obviously many of you know us as a chip manufacturer, and we've been quite predominantly there driving forward Moore's law, contributing towards the miniaturization of chips at a certain rate. And however, Intel is much more than just like a chip manufacturer company. We actually quite, let's say, in the recent decade, moving towards being actually a computing company. And our vision is obviously to be able to have computing technology embedded everywhere, and through this somehow be able to enrich lives of every person of it. So Intel itself has actually quite a big software development division. So we have really, I don't know, many of you are potentially familiar with Linux, for instance. Intel is the second biggest contributor to the Linux Foundation in terms of code in the kernel. So this is just an example of, and there are many other projects where we kind of work on Android and other platforms, delivering solutions also in the cloud area. So Intel is much more than just chip. It's basically a company that is able to deliver end-to-end solutions, including software stacks. And obviously, we are mainly known for processors that are really serving the high-end market, like servers, desktops, and so on. But also in recent years, obviously, there's been an explosion of mobile devices. Many of you have iPads or like smartphones and so on. and Intel is as well playing there an increasing role. And the emphasis has been not necessarily always on best performance, but more also on energy efficiency and also having some form of wireless connectivity on chip on this device support. And obviously, there are many competitors in the wireless space, which is quite important, and as more and more devices become basically mobile. But I think there's a next wave of technology coming out, which is called the Internet of Things. This is what the whole summer school is about. And Intel sees this really as core of their vision, so to computing technology, embed computing technology everywhere. And we see it as well as a huge growth area in the future. So I think you're all really in the right area, in the right domain, at the right time. Yeah? So, and one of our first, let's say, experience in this let's say, low-end processor space is the Intel Quark. And it is basically one of the first products in the roadmap of smaller core devices appearing on the IoT market. And this Intel Quark SoC is basically also key, or let's say the foundation of the Galileo platform and other Intel platforms that will be emerging in future. So, I mean, Galileo itself is basically a platform that targets the makers and maybe entrepreneurs segment, or maker-friendly entrepreneurs. It's Arduino compatible, so you can kind of plug in different Arduino shields from pinout, so the connectors are same as the Arduino Uno. And it has a full Linux stack at the same time, so it's an Arduino with a full Linux stack. And this offers you, obviously, also more possibilities to kind of tap into this large ecosystem. So what I have here in this tutorial is the Generation 1 Galileo that came out last year. The Generation 2 has just come out, so it is, I think, a few of the first ones are just being shipped. Unfortunately, they weren't available to me at the time, but I think the Galileos are, in terms of, let's say, the programming environment as well as the core features, pretty much the same, apart from a few improvements on the board that you have in terms of maybe slightly improved GPIO performance, more precise ADC, so if 12-bit or 10-bit available in Arduino, better onboard power supply, so those are a little bit sensitive, and I will explain exactly what I mean with that later. And also, you have a few more connection options with it. Something, I don't know, has anyone heard about Intel Edison? Just one or two, yeah? Okay. So that is basically also something that will be officially launched very soon. It's been announced at a conference in Las Vegas, the Consumer Electronics Conference in Las Vegas. It will be basically also a Quark-based device that targets IoT consumer products themselves. So really going, not just for the makers and space, but really going into mass market devices and wearables. It will be even smaller. It's like a form factor of an SD card. It has on board. It will have on board Wi-Fi, Bluetooth. It will have also like enough power to kind of crunch some algorithms that require maybe a bit more processing. And it has really like a low energy and small form factor that makes it useful for a kind of wearable type of thing. And also the toolchain is compatible to the toolchain that we use for the Galileo. So whatever you learn here today, you will be able as well to utilize on the Edison, maybe with a few adaptations, but the base ideas are very similar. And then utilize this platform or the skills on this platform as well once it becomes available. Any questions so far? Good. Oh, yeah. So I know the slide is not very well visible, but just to give you a little bit of an idea of Intel Labs Europe. So Intel Labs is actually the research arm of Intel, and we have across Europe, nearly like 50 different locations where Interlabs is kind of operating. And I'm based myself in London. It's number 9 here on the list, the Collaborative Research Institute on Sustainable Connected Cities. So obviously, while we do like research on let's say manufacturing technologies and chips and things like this, we also do research in application spaces like future cities. And this is something that is also a very important growth area for IoT that we see. And we've basically set up a collaborative research institute on cities in London, where we work together with researchers from UCL and Imperial College. So these are like 2 London-based universities. So Intel gives basically those universities money, and we work together with basically their staff and PhD students on exciting new things in the space. And our mission, obviously, is to see how we can use this technology to enhance the social and economic environmental well-being in cities. And obviously, try to see how we can harness information available in the city to kind of enable new insights that allow us to improve how cities operate and work, to understand how we can maybe better interconnect people in communities within cities, to understand better as well how we can opportunistically reuse this emerging infrastructure, like, you know, pervasively available smartphones for providing, for instance, connectivity services in the city in an opportunistic way. And also looking at how we can leverage this technology to also influence actually behavior of people in the city. Because in the end, a lot of the city efficiency and or the problems as well are based on how people act in the city. And if there's a way, for instance, to make people, let's say, choose more sustainable transport choices, or make sure that people, let's say, act more environmentally responsibly when using energy and so on, this will have a quite big role to play. So it's not only technology, but it's also kind of how we can influence people with technology to become, let's say, a better sustainable, or let's say people with just better citizens in general. So this is kind of the work that we do. So obviously the IoT applications in an urban environment can be really diverse. So, you know, they can range from looking at optimizing transports, traffic flow and logistics for production in a city, over to, like, you know, the home environment, how you manage basically resources available there, overlooking to things like the smart grid, so like, you know, in utilities, water utilities, how you can make more efficient use of the resources and the networks that are there. Looking as well at how you can make maybe shops more responsive, enhance consumer experience in this environment. Also looking at hospitals, healthcare. So it's a really diverse kind of opportunity, a diverse space, application space. And I think many of the, let's say, challenges in this kind of areas can be kind of overcome through IoT technologies, and we're trying to look to kind of incrementally improve basically how cities work. For this as well, we have a quite hands-on approach. So while it's good to do obviously research, you know, in your lab and in simulations, we also try to kind of bring out research into the wild and really build prototypes and experiment with it. And so, for instance, with quite a few projects currently in London that look at instrumenting environments like cities or areas of cities or parks. Even we kind of work together with schools, for instance, where we bring Internet of Things devices into schools, and we can see how we can actually enhance the curriculum, the learning curriculum of the students and the experience around it. We look at air quality, for instance, in cities. So Enfield is one of the boroughs in London, where we kind of try to raise awareness of air quality and pollution, and try to work together with the municipality or with the council itself on kind of solutions, how we can use this knowledge then to kind of improve policy making around it. We look as well at Hyde Park. I don't know, has someone been in London? Hyde Park, it's, I think, one of the biggest parks in Europe. Here we also deploy sensors to monitor the ecology, water, soil, pollution, noise, and we try to see how we can improve the operational efficiency of the parks, but at the same time, how can we also make the visitor experience or enhance the visitor experience itself. And also we try to look at some behavior change projects, like for instance in Brixton, where we kind of look at we work together with kind of schools and students, pupils. So a lot of like traffic is actually caused through school runs, like people dropping off the kids in schools. So we try to kind of work together with on some of innovative solutions, applications where we can kind of encourage actually parents not to take the car, but find other ways of getting their children to the schools. So these are just some examples. And in many of these deployments, we actually utilize the Galileo, so the platform that you actually see here. So for instance, we've built air quality monitors, weather stations, interfaced them, and other kind of environmental sensors like soil monitoring and so on. And these solutions are being are operating in these environments, providing real data that we can basically then act upon and utilize for our further research in this space. Okay, we also do more playful things with it, like so not me personally, but other colleagues are kind of really as well engaged in like going to maker fairs, for instance, where you interface with all sorts of people that are kind of interested in building like a bottom-up Internet of Things, you could say. So like playful interventions with kids and students where they can actually build small things and become part of the experience. Connect, for instance, a bubble machine to the Galileo. You can tweet something to it, and it starts bubbling things out. So it's just like small playful things. And other things, for instance, this is by the Copenhagen Interactive Design Institute. So, for instance, it's a social city toolkit where what it does is basically it's for instance a backpack where you can have a Galileo in it. It's internet connected, and based on which area you currently walk in, it will pull basically Twitter feeds from it, and it will then basically using one of these how are they called, the megaphones. It will kind of broadcast what's actually happening online in the real world. So these are just some examples of what kind of people have come up with what you can do in this space, more playful as well, and also enhancing basically experiences in an urban environment. Okay, so I think that is kind of just a brief overview of let's say what Intel is doing, or what we are kind of involved in Intel Labs and in London. And I think now I would want to maybe move towards basically the tutorial on the actual devices. I don't know, are you still copying, just to understand where we are? Yeah. Has anyone doesn't have anything? Everyone has the files necessary for the ID? Okay, that's cool, that's efficient. I think it's better than just using the Wi-Fi and downloading it. So, yeah. Okay, so before we kind of plunge in, I just wanted to understand. Okay, so quite a few of you have already used an Arduino. So it's basically, for those who don't know about it, it's an open source hardware and software platform for building kind of electronics projects, and it's kind of emerged from the motivation to kind of in an easy way provide sensing interaction capabilities that you can use for kind of interactive design projects and so on. Let's say artists that want to kind of use technology to kind of influence it, but without needing to really be very, very technical. Yeah? or like hobbyists, or people who really just like to create things. And it's a platform that you can basically, it's a physical piece of hardware where you can kind of connect different types of shields, or like sensing enhancements or communication enhancement to boards that are kind of compatible. It has some form of libraries which allows you to very easily use those then. And it comes also with some form of integrated development environment. And this is the one that you actually pull down onto your laptops. So you can, in a very easy way, in a C-like language, program a few instructions, and you can then control easily the IOs that are available, read IOs, or the communication interfaces that you have attached to it. Okay, so I think one of the let's say most widely used is the Arduino Uno, and it's based on an Atmega chip, so not an Intel chip, but an Atmega chip. And I think most Arduinos that are out there are either Atmega or ARM based. But obviously, it comes basically with a kind of standardized connector set, which exposes basically different IOs in a uniform way. And so basically, this allows basically people to develop interesting sensing solutions or adapters or communication interfaces that many others can just plug on and use straight away. So it kind of allows you to form an ecosystem where you can then plug and play different things in an easy way. And Intel has recognized as well the importance and of this community, as well as basically of the ecosystem itself, and has then basically tried to, when they brought on their own Arduino compatible node, the Galileo, it uses the same pinnings, or like as the Arduino Uno itself. So that's kind of like a quick look into the on the schematics of a Galileo. So you have in the middle, like obviously the Quark SoC. So it's not an Atmega, but it's an Intel chip in this case, and it has quite a lot of let's say connections. Like it has a mini PCI bus where you can put in different PCI-based cards. It has a micro SD connector, host, client USB connectors. It has basically Ethernet, UART, and then different GPIOs connected to these pins, as well as ADCs, like analog digital converters, where you can also read in analog signals, and obviously some memory and so on. So it's kind of like a it offers quite a few options to interconnect. This is taken from MakeSign, like a magazine in the makers community, and so they blogged about what's so great about the Galileo. So it offers basically Arduino shield compatibility for most of the shields. Obviously, there are some limitations with the speed of the GPIOs for some boards, but I think many of them will work out of the box. You have the familiar Arduino IDE that we can use, so the ones that I just distributed to you is kind of the standard IDE, but with a few Intel-specific aspects. You have micro SD cards, where you can use for storage, serial connectivity, different options. It works also with PCI, so like the Wi-Fi modules that you have in your laptop would work as well in the Arduino. And in fact, I've attached to each of them one so that you will use in the tutorial. It obviously has the library compatibility from the Arduino for the Wi-Fi and Ethernet. It has a real-time clock on it that you can utilize. A USB host port as well, so not just client, but it can actually act as a USB host to other devices, so you can attach different USB devices to it. Obviously, it's Linux on board, which is kind of like a big leap, and also obviously SPI and other interface support, like for I2² and so on. So it provides you like with a flexible platform, but with the power of Linux as well. And this is how it looks like. So I think it has basically a processor, RAM, and so on. But I think maybe once I distribute them You can have a look and match again on the picture. So maybe just a few as the hardware features. It has a 400 megahertz quark SoC, 512 SRAM, 256 DRAM, an 8 megabyte flash on it, micro SD card. You can put like the ones that we have are 4 gig, but you can even put bigger ones on it. Yeah. So I think most of it has been mentioned. And it's quite interesting as well. Is basically this Arduino Shield ecosystem. So there are really hundreds of shields already available. They offer different types of things, you know, for robotics applications, different comms interfaces for using a GSM modem, for instance, using 802.15.4, using Wi-Fi or whatever, different sensors, displays, solar panels, you name it, and most of them you can utilize then as well, just on the Galileo itself. Okay, so a little bit about the software. So basically, although we have like a Linux kernel running, so you have kind of full access to the Linux. What we do is like we emulate an Arduino. So basically, you can load Arduino sketches. So these are like small programs that you write in Arduino, develop in your Arduino IDE and upload them, and they kind of execute on it. Basically, usually just once you can run just one sketch at a time. Yeah. So if you use basically the Galileo without the SD card, so just using the Linux version that comes on the flash, you will have to obviously upload a sketch whenever you reset a node. But on an SD card, it can save the last sketch. So when you boot up or reboot the Galileo, it will run the sketch that you previously uploaded. Just kind of for you to get an idea. And obviously, it has certain Arduino I/O adapters that are written, and that map down basically to all the hardware I/Os exposed for Linux. So I've mentioned Sketch a few times. So what it is kind of like a way of kind of structuring your program that you write on top of the Arduino. So it has basically two main functions. One's basically encapsulated in a function called setup, and that's basically code is executed just once when you initially load the sketch. And then there's basically another routine, which is called loop, and that's something that basically runs continuously, and the code that is in it is kind of periodically run. So things that you want to do just once, like initializations and things like this, you put into the setup thing, and things that you want to routinely be performed, you put into the loop. And then you have also outside space to kind of declare global variables that you may want to use. So like certain variables where you want to store certain values that you use. And then obviously you can also comment your code, but it's just that. So it's not much more to it in the end. Maybe also something that you will have to observe later is there are two differences. So you have a reset button and a reboot button. Yeah? And a reboot button will kind of reboot the entire board and the Linux that runs on it. The reset button will just reset a sketch that you run on it, that will a sketch you run on it. So this is just two levels of control that you have then. Okay. So maybe also a little bit more on the software stack. So obviously we have basically a flash memory area that has a bootloader for the Linux and some BIOS information. Then you have basically all your Linux kernel and drivers that are used for kind of the interfacing of the GPIOs and Wi-Fi modules and so on. And then there's some user space code where you kind of have an Arduino sketch binary itself that you upload, as well as basically a sketch loader. So it's and then on the other side, obviously you have your editor where you write basically your sketches, and then you have many like Arduino core libraries that you will use, where basically your sketch gets compiled in that binary, and obviously linked against these libraries. Any questions so far that you may have? I know it's a bit technical for some of you, but...
Could we see an example of it?
Yeah,
maybe?
Yeah, we will, in a minute. So, sorry.
Yes, I may have a question.
Sure.
I don't know if you can explain a little bit the main motivation or difference between your Galileo board and other Linux-based like Biograd or Raspberry.
Yeah. So I think, for instance, if you look at Biograd or Raspberry, they are not Arduino compatible. So they don't have like a shield connector, as for instance the Arduino Uno, and it's not so straightforward to kind of adapt those shields to be used on this type of platforms. Also, they will not natively support, for instance, Arduino sketches running on them. And I think Intel's idea was, okay, look, there's a big community already out there, a big ecosystem. People that kind of, from different backgrounds, like, not just maybe hackers, but also people who are like designers, artists, who kind of use this kind of Arduino ecosystem and who actually make very interesting things, new things that, tech is sometimes maybe don't do. And I think kind of leveraging this community and being able to offer basically a platform that kind of allows you to easily just reuse this shield ecosystem, as well as basically offering a way of, in a simple way, writing sketches to non-skilled programmers, let's say. So in a simple way, I think that was one of the main intentions. So.
Okay. There is the Raspberry to Arduino shield.
Yes. So I mean, but obviously you have a Raspberry to Arduino shield, and on top of this you put, and obviously the Galileo does it natively.
So I mean, Galileo is like a power boosting the Arduino. You could have processing power.
Sure.
So
Yep.
if you name some few use cases for someone instead of just using a single Arduino board, would use the Galileo. I mean, what sort of projects would I use the Galileo for instead of just taking Arduino Uno or some other small board?
That's a good question. Yeah. So I think overall, so one of the power obviously of having like a Linux system is that you can reuse a large set of, let's say, tools existing around it and also code existing around it. I can easily, for instance, compile a Python script, with or like a Node.js script. Run it on the board to complement certain functionalities and features. Something I can't do on an Arduino, on a normal Arduino. So of course there are Arduino libraries that do some stuff, but for instance, if you want to use some MQTT publish subscribe kind of messaging protocol, there is a Python library. Just install it quickly and it works. So I think this kind of flexibility you don't have really on an Arduino. You are kind of tied still in the capabilities of obviously your the platform itself, and as well what's available to you as a developer. Then and that is kind of you have features, but not. So for instance, we are using those to kind of really we can run the Galileo in field. We have kind of network management software that runs on it, where you can push dynamically code if you want to and reconfigure it. This is stuff you can't easily do with an Arduino.
Simplifying the development process more enhanced. Simplifying the development process.
Yeah, and give more opportunities to kind of tap into. I think that's the way forward. And at the same time, it gives you as well people who really don't want to use all, let's say, the Linux and let's say Python or whatever. They can just use it just to upload a sketch and run it. It will work, But people who want to do a little bit more than just and try to somehow maybe leverage other ecosystem puzzles, they can use as well basically these tools. So increase flexibility.
I think some project accounts are missing because it's not clear to people why they would use a Galileo versus an Arduino versus So for further also community expansion.
Yeah.
I don't know if you're going to have some examples that demonstrate this difference, but it would be useful to make it more clear. Yeah,
I think so. I mean, obviously the Arduino community is also, sorry, not Arduino, but let's say the Galileo community is something growing. I hope maybe some of you will join. So as well, and maybe I'm looking forward to see also some examples emerging from these days now. Like we have 1 week to kind of work in between on it, and maybe we'll also get some nice ideas from you in this space. So, thank you. Okay. So I mean we're very nearly there. So just really 1 or 2 more slides, okay, and then we'll hand over the Galileos to you, okay. But for you to understand, I've mentioned a few times that there's a Linux running on it. It's basically it's a Yocto Linux, so which is basically Yocto is an open source collaboration that provides certain templates and tools to build your own custom Linux version for a particular hardware platform. And so it's not yet another Linux distribution, but it allows you to create a custom one. And obviously, it has basically quite a different ecosystem of tools that makes this happen very efficiently and in an easy way. And it gives you, on one side, the convenience of a ready-to-run Linux distribution, but at the same time, it gives you more flexibility to basically build an optimized stack for your platform. And you can easier port as well a particular configuration to other kind of platforms. And so there's basically a reference build, which is Pokey. It's a complete basically Linux with kind of different packages, metadata. So per default, when you run or we generate basically in Yocto, it will generate basically a Pokey distribution, and you can customize this with metadata. That's not really important for most of you, but just a little bit of an understanding of what this Yocto is about. And obviously, it pulls code from mainstream kernels, and there's a release every 6 months. And so there's basically one Linux image that is kind of customized for this particular Galileo that you can use. There is basically an official SD card image that you can download, and there's also like one that is a little bit more enhanced. That is not an Intel, it's an Intel employer, but it's not an official Intel image, which allows you to kind of have package management and some more advanced features. So I have a GCC compiler as well installed, so you can compile C code on it. So for the tutorial, I'm using this image here. Yeah. But if you want at home, wherever you are, the default type of image is this one. Okay. So and there's basically a big community. About Galileo, so there are support forums where you can read about it. Obviously, there's a makers community, so I would encourage you really to kind of join and sign up. It just takes a few clicks and an email address, and you being part and you kind of accessing people expertise in this community. So it would be nice if every one of you could kind of join this community. And obviously, there's also many other like tutorials out there that you can use to complement what I'm currently presenting, like things on SparkFun, and also if you were interested on other Arduino shields and how you can use them, there's plenty of information on the web for you. Okay. So I think now we've reached basically the end of maybe like the introduction part. I think what I want to do now is kind of to hand out the Galileos. It'll be obviously if we'll go quickly through like installing this Arduino development environment, if you haven't done so yet already, and then we can start getting started with just running a very simple example, and then I will try to go through like other basics that may be then useful and introduce you to kind of different capabilities of it. Okay. We should be able to connect to the Galileo via Ethernet from your laptop. So you can basically telnet or SSH into it, and you can see the Linux. I hope, so what you can also do is like set up the Wi-Fi, and I'll show you how you can do that. So there's an onboard Wi-Fi card that is on it that I kind of added to the kit. We'll just do a very simple SSTP so you can copy some files if you need later for your work, and also a little bit something actually on the Bluetooth for those who want to actually connect as well, a Galileo via Bluetooth. Okay. So so maybe just having a look a little bit at your board, you may have noticed that there's a big Ethernet port sitting there. So the SoC has basically a on the chip support, but you need like an external PHY support for it. It has basically as well, you can see here some PCI mini slots where you can put in something like the Wi-Fi card, which you have on the back of the board. And it kind of allows you to kind of interface different types of devices. Obviously, you can also use the USB for kind of attaching any kind of dongles and so on to it. And you don't need an Ethernet shield, so it's on board. Many Arduinos will require actually an Ethernet shield for this to work. And it's basically, you can use basically the standard Arduino Ethernet drivers to make it work, okay? Then there's the Wi-Fi, as we said. So you will have noticed there's this small Wi-Fi adapter. This is one that you will find, for instance, also in laptops and stuff. I had to kind of get an additional bracket, which is like the silver metal plate in the back, so it nicely fits into it, okay? And there are 2 antenna connectors, okay? And this is for diversity. So I've given you each of you one antenna. So go to the primary antenna connector. I think it's called A or 1 or something like this on it. Yeah. So it's the main one. So use this one here, okay? So to connect your antenna to it. Just a little clip-on antenna, okay? So you can see it here, right? This is what I was talking about. And you just use this one, main one. Clip it on, okay?
The one on the left or the right?
The one where it says one main on it.
Ah, one main.
Okay. Good. Okay. So maybe something, I don't know if you've noticed, but so we've given you all an SD card to stick in, right? So basically you are actually booting from a Linux that is on the SD card image. And that has Wi-Fi support. If you unplug the SD card and you reboot the node, you would be booting from a flash image, which is much more smaller. And this doesn't have Wi-Fi support. It just has basic Ethernet support. So just for you to know, okay? So for the whole tutorial, we want to use the SD card image. But later, if you should be the lucky one winning a Galileo to take home, or should you consider buying one? It's good to know, as a feature. Good. So basically, as well, the Ethernet drivers. You can just use basically the default ones. It will work on both, on the basically small image and on the SD card image. And you could basically access it via basically Arduino libraries and use it normally in your Arduino sketch. But obviously as well, you can via Linux have also full control on it. It's basically an Ethernet interface underneath, which you can if up, if down, and configure. Okay. So the Wi-Fi software, as I said, will just work on, it's just compiled on the bigger ones. There are a few for default supported, so the module that we got is one that it kind of comes out of the box. There may be a few others that will work out of the box, or some that you can just compile to work. So, but usually most of these kind of modules, online you will find some information about it. And again, they can make use of the standard Arduino Wi-Fi drivers libraries. Okay, so what we want to do now is kind of to from your computer connect into it, and you've got all like a Ethernet cable. It's not a cross-connect cable; it's a normal one, but the chip will understand it and automatically configure it to work. Okay. What will happen is basically that your PC will need to get some form of link local address automatically, which it discovers. For it to work. I've tested it on Windows myself. It worked pretty well. I don't know, Michele, on Mac, do you need to configure something special for it to work on Mac, on the PC side, on the Mac side? For the Ethernet interconnection. Just in the same subnet. So do you need to configure something special, or will it automatically? Okay, maybe you can explain that in a minute. Okay. Perfect. Okay. So, okay. Okay. So in order for this to work, you will obviously need to kind of configure your Arduino itself. And the way, the Galileo. And how you're going to do it is we will upload a very simple sketch that uses some system commands to configure the networking settings. Okay, just 2 lines. I'll show you in a minute. So what you do is you create a new sketch. Okay, now it's your time to create a new one. So in it you just populate the setup function with 2 lines. Yeah. One of them is system telnet d minus l bin shell. So basically you will start some telnet server on the Galileo. And the other one is you will configure the Ethernet interface with a Linux command. Okay, and that should basically configure the networking settings on your Arduino. And you can use the same command as well on Mac or on Linux to configure your local interface, which connects from the other side. In Windows, it should kind of auto-discover itself. And obviously, try to use a different IP address, maybe 1.2, 1.3, whatever, in a local subnet if you want to do it on your PC, right? But Windows should sort it out automatically. And then after running the sketch, once Windows has discovered it, or you've configured your Linux, you should be able then to connect to it in the next step. Okay, so you will get all the slides from me later. So okay, so I don't know if you can read it. If not, not really. Okay, let me do something. So the next step, what we're gonna try to do now is we're gonna obviously get the Wi-Fi ready for connection. Okay. For this as well, your laptop should be on Wi-Fi. Maybe just also to understand, because it's multi-homed, right? We'll do a lot of things with Wi-Fi later, right? Because I want you to have direct internet connectivity, we will shut down the Ethernet interface again, okay? But you need to be logging on through your Wi-Fi to that node. There's a network here that you can discover, which is called, what's the name again? Yeah? Huh? Congress na Sala, exactly. The password for it is SenZations 2014, all lowercase, with Z. SenZations 2014, lowercase. Shall I put it up, or will you remember that? Put it up, yeah? Okay, I'll put it up then. Okay. So this is kind of from your laptop, okay? Not. Don't do anything on your Galileo. It's just on your laptop. Connect to this network. Okay. Okay. Then, so if you type into your shell ifconfig, then you should see all the network interfaces that are available. If you type in, so basically it will show you, for instance, just for you to understand, many who are familiar with Linux or Mac would know it. It shows the IP address of your interface that you configured. This is the MAC address, and this is your interface identifier. So there's Ethernet, loopback. Wi-Fi you may most likely not see it. This will be WLSD, which we have to first configure to work. So, but for the time being, I just want you to kind of connect your laptop to the network. And now we will start a new SSH client, okay? So, but before that, if you type, for instance, iwconfig into your shell, you should be actually able to see something on your wireless interface, if it's properly plugged in. Do you see WLAN 0? Yeah? Yeah. Yeah. So that is basically your Wi-Fi hardware that is plugged in the back. Okay, we'll use it in a minute. Okay. So now, so usually, don't do it. I'm just going to step through it. It's already configured. Usually, for you to kind of configure access on the Wi-Fi, there's a tool called WPA passphrase, and if you just type this one in yourself, the ESS ID and the password, it will generate a small file, or like some output, that you can put in a configuration file for your Wi-Fi to work. And you can just bring up the interface with if up WLAN 0. So I want you now to bring up your interface. Just type, as you don't have to do this step, it's already done for you, but this is how you would do it usually, okay? But now just type in if up WLAN 0. It will take a little bit of time. It's a script running, and it will try to kind of acquire an IP address from the router, and then it should actually have the settings configured. So if up WLAN 0, you would see something like this. So you obtain a lease, and you get some form of DNS record. Okay, so after your initial networking experience, I hope it's been somewhat a successful one. We look at different I/O options now, yeah, on the Galileo. So obviously, for those guys who are familiar with Arduino, this is like boring stuff. But I think I just want to kind of very briefly touch through, you know, how can you now send something, do something on the Galileo using the Arduino. And for this, we will use the Growth Starter Kit as well. So the one that you have in front of you, yeah. So and some of you have played. So in principle, each Growth Starter Kit comes with a shield like this. Okay, I'll show this later as well anyway. So obviously, some of you have the shield in the starter kit, but some of you may not have a starter kit directly, so you can get a shield from me in addition to it. And we will reuse the sensors across the tutorial. Okay. If you look at the Galileo, you have different types of I/O options. Okay. So you have basically different options for serial communication. One is a funnily designed RS-232 serial 3.5 millimeter jack, what you use from audio cables. And this is a way to connect to the Galileo using some form of USB to RS-232 kind of cable, like this. Quite complex parts to get. That's why, I mean, so you can get this, through this you can connect to it, have basically a Linux shell and do stuff with it. But that's why we're using Ethernet, which is a bit more simpler option to do, okay? But obviously if you're using Ethernet and Wi-Fi at the same time, you can be a bit confusing. So then we have other serials that are connected through the digital, it's like a UART through the digital I/O, so we'll show you. We have also an SPI connector. It's a JTAG connector for some programmers, and there's some analog inputs as well here. So I've seen already a few of you have put some LEDs into the GPIOs and stuff. So the 14 digital pins here, I2 square, TWI. This is kind of what's on the normal Arduino bus, and there's also the 6 analog inputs that you have. Okay, so. Maybe just briefly start with serial communication. This is something quite useful if you want to debug some stuff. So let's say you write some code, you can basically, with your USB cable, you can basically write some stuff back to your PC via a console. Or you could also potentially send some commands through it as well. Yeah? So as I said, Galileo has different options. So you could have serial over RC32 over the USB port or over the UART, which are on the connectors. And we will be using, obviously, for some, we will be using the USB cable that you use for the programming of it as well, sketches. So in general, so in order to initialize basically a serial read or write, you do it via very simple syntax. Just say serial begin and the baud rate. And there are different serials, serial 1, whatever. For you, just use serial. And then what is meant is basically the one where the USB is on. And there are different baud rates supported by the Galileo. So like speeds, basically, in how you exchange packets, all of packets frames over the serial. So you need to set this baud rate, basically. So for instance, if you use serial begin, you will open basically the port with this type of baud rate. Then there are different ways, so there are not many commands, but different ways in order to kind of print to the serial port. So the serial print value or print line value will basically output some variable onto the serial as a human readable ASCII. And if you would, for instance, type serial print SenZations 2014, this is what will be printed on your serial board. And likewise as well on your also integer values and so on. And you can obviously as well have a function with a format. So in this case, it will basically just print the first two decimals of a serial one. And you can also basically do binary data over serial port. For this, you would use the write command. So, obviously, in this case, data is sent as bytes or series of bytes, okay, over the port. So these are the basic options that I think every Arduino will offer. So this is for the writing, right? So if you're in a Galileo and you want to read something coming from your computer, for instance, or from another device that you connect via serial, you can read using serial read. And often it's quite good to first kind of see if something's available before you read, so you know how much you have to read is coming in. Okay, if there's nothing, you don't have to read. Yeah, so that's a good kind of way of doing it usually. And data can be read also in chunks. So for this, you would say serial read byte, and you would use the length, for instance, that is available will return, and it will copy this into a buffer. Yeah. So as I said, so in this case, the buffer could be a char array or a byte array, and the length is obviously what you want to read. It shouldn't be longer, obviously, than your array it is that you define. Obviously, you can also set a certain timeout to wait for on a serial using the serial set timeout command, and the value is here in milliseconds. Okay. So if you open your Arduino, or just go back to Arduino shell, there is a handy tool which is called a serial monitor. Yeah. And a serial monitor basically will provide you with a way of receiving things from that are attached to this COM port that you have. So basically stuff that you write from the Galileo, or you can use as well this field on top to send something to it. Okay, so obviously in order to be usefully using this, you will have to listen to it. So I think I've prepared a few exercises that you could go or step through. I think so one for them would be, for instance, to kind of store your name in a variable and write it using the serial write or print a line, and then you could receive it back in your terminal itself. Okay, so I think you could also write an echo server where you can send something which returns it back. So this type of thing, but I don't know how familiar or how experienced you are. But I think in essence, maybe just try a simple example where you would basically initialize your serial port at the beginning and maybe write something to it using basically maybe a print, just print to it, and then see what comes out at the other side in your terminal. Is it okay? You think you can do that? Yeah? Everyone enthusiastic? So you just do a serial begin, let's say with a baud rate of 9,600, and then serial write. Okay? And the begin you initialize usually in your script. Remember, you can do a loop and you write every second something or something like this. Yeah. Just give it a go, and then use the serial monitor built in your IDE to monitor what's arriving back. So I give you like 5 minutes for this, okay? And then I will move on to the next bit. So I'm going to be now moving on to the sensing part, okay? So in the sensing part, you got a growth starter kit, okay? It has basically a different range of input devices, as well as which are analog or digital. So you get a sound sensor, a rotary angle sensor, it's like a potentiometer at the end, a temperature sensor, and a light sensor. Yeah? And obviously you can connect them to ADCs, the ADC connections, and read basically analog values from them. Likewise, there are like digital devices like a touch sensor or button, which either show high or low. Okay? And these ones you will be using. And then on the other side, you have also output devices, actuators, which are basically LEDs that you've been playing around with. And there's a little module where you can just stick on a LED and they just observe like a little wedge, so it will be aligned with the LED to put in. There's a buzzer as well that you can use, play with. It's a relay switch, a display and a servo. Okay. We will not be using the display and the servo. They will require a little bit of. There are some Arduino drivers for it that you can play with later, but we'll be using the buzzer and the LED a little bit to play around with. Okay. There's a base shield. Okay. So it's in every growth starter kit, and I would like you to take this base shield out. It's underneath the LCD display if you don't know where it is. Okay. So it's a base shield like this. Okay, so each of you should have a base shield now, and stick. If not, then you can get one from me. But it's in the growth starter kit, and those who couldn't get one can get one from me here. And then you need to stick it into your Galileo Arduino device. Okay? Anyone needing a base shield? Okay. So, and I think you see the pins are like aligned. So make sure you put them properly into the Galileo. There you go. Okay. Excellent.
We have 3 sets here. One shield.
Yeah, sure. Okay. So, as you see, like the base shields have different ports to it. Okay. So we've seen that we have digital ports or GPIOs. Okay. We have analog ports where the ADC converters are attached to. Okay. We also have a UART. We have basically I2 square, which is basically a serial com for sensors or other kind of devices that you can connect to, digital devices. So these are all kind of like available. Obviously, your Arduino itself has more digital ports that are exposed in this. So here you have D2 to D8. Yeah. But actually your Arduino has more digital ports, which I will be telling you about, or like the Galileo. But at least those you can use in the growth starter kit, and there will be enough for most of the things that you do here. And then here are these analog, and there are 6 usually, 4 are exposed here, okay? And this, the principle here is kind of that you will select an appropriate port. Let's say it's an analog sensor, which I showed. You will stick it in the analog pin. If it's like a digital sensor or like a digital actuator or whatever, you would put it in a digital thing. And most of them will work out of the box, okay? Apart from the servo and the LCD, okay? So, briefly, we have 14 digital I/O pins, which can be configured as either input or output, okay? 12 of them serve as general I/Os, and 2 are occupied by UART, which is like another serial comms. So pin 0 and 1 are for UART. So pins 2 to 13 of the digital pins you can use, and you can configure them either as input or output. And 6 of those, which are basically marked with a little, how do you call it? Tilt. Very good, thanks you, Susan. Those can serve as PWM, which is like pulse with modulation. So what you can do there is you can kind of emulate an analog signal coming out of it. I'll explain you briefly. Obviously, they can work in 3.3 or 5 volt. There's a jumper on the board to configure them. Don't change it now, but I'm just saying this is something that you can do. And obviously your GPIOs, they can drive maximum 10 milliamps. Okay, so you cannot really drive something more significant with it. Yeah, something small is fine, like a LED. But if you want to drive something like, you may need to. You may have to. Yeah, buzzer, very good. So it may work. So, but you may be able to. You need to have a transistor circuit behind the GPIO in order to switch bigger loads. Okay. But for a tutorial, the stuff that we have is safe. But for future projects, if you want to use the GPIOs directly to drive some things, you may need to have some transistor circuit behind to kind of not to fry. And obviously, the maximum total on all digital pins is 400 or milliamp or 100 milliamp overall. Okay, so I said that you can configure them both as inputs and outputs. The way to do it is just use the pin mode command. Yeah. So you type pin mode or a function. Yeah. You define which pin. So this is for the digital pins, as I said. So 0 to 13 or 14. Right? And then you configure them either as output or as input. Okay. So in this case, 13 becomes an output. In this case, 4 becomes an input. And actually, if you look at your initial script, the blink one, you would have seen actually this type of command in the script itself. So maybe you just revisit the blink, and you can see that you configure basically pin 13. This is the one where the LED is attached to on the Galileo board as an output. Okay. And then, if you configure it as an output, you can write to it as well. And it's again very, very easy syntax. Digital write, and then pin, and then high or low. Obviously, it's digital, so so you either basically switch on a LED or switch off a LED, or you just basically put the output to high or to low, 5 volt or 3.3 volt, depending on what is configured, to. Again, the blink example shows you how to use it actually. Yeah, so if you have a little look at the blink example, you'll see how this is done. So this is like the blink one, right? So then there's also digital read. So obviously, if you configure this one as an input, you can read from it. Okay. And again, here you will just say which pin you want to read. So let's say you configure pin 3 to be an input, and you want to read what's attached to pin 3. You can do that. So for instance, if you have a button connected to this digital pin 3, you will know if it's pressed or not. You can basically configure it as an input, and then you can sample it. Okay, is it pressed? So is it high or low? Yeah. So what depends on what is you put, what is attached to the input. Okay, is this clear? So it's very, very simple in the end. So, and that's why it's quite accessible as well for hobbyists and people who are not really into it. This makes actually Arduino quite beautiful for making it easy to create such projects. So maybe a small exercise that you could do maybe later, but maybe turn one LED of a button. So basically, you can combine maybe a switch and a LED, or a switch and a buzzer, or a touch and a buzzer. And when you basically configure one as input, one as an output, obviously press, and then you trigger the other. So you turn on the light when you press, or you turn on the buzzer when you press it. This is something that you can kind of trial out. But because of the time, I will just go through it I'm very happy to kind of later sit down with you together and kind of play around with it. So I've also kind of some solutions how this would work. Then we got 6 analog inputs as well. So these are basically attached to the ADC converters. The converters themselves are 12-bit, but the way they're exposed on the Galileo in Arduino, it's 10 bits. So if you directly work on Linux, you can get actually access to 12 bits, but in your Arduino you just have 10-bit resolution. Okay, so you can have so if you attach a voltage between 0 and 5 to it, it will read values from 0 to 1023 in this case. In Linux, you can have up to 4095. And again, you can configure them as also to act as digital pins if you want. And you can also use the analog outputs. You can do an analog out via PWMs, not here. So this is just for input in this case. So analog is also very simple. It's just analog read, yeah. And so basically, you just basically connect something in your analog, like let's say one of the analog inputs that we have into it, like a light sensor, for instance. Yeah. Just plug it into an analog input pin, and then you should be able to just obviously make an analog read onto it, and you will get a value between 0 and 1023. And something very useful as well is if you want to kind of map these values maybe to different ranges, there's a map function that allows you basically to map a value from one range to the other. Yeah. So, for instance, a value read in between 0 and 1023, you can map it into a range from 0 to 255. It is useful if you want to use this and then trigger something on the digital side. Okay. Again, all of these sensors, one of them you can just connect to an analog pin, maybe in one of the breaks or a bit later throughout the tutorial, and play with it a little bit. Okay, so if you can get a value from it and just have a look, print it to your serial port and have a look at it. Okay, and then the last bit basically is so we have a PWM as well, so a pulse width modulation. So you can, for instance, use it to set a LED at different light levels, so kind of generate a voltage which is not only 0 and 5 but in between, or drive a motor or anything like that. And just the principle is like usually like you have a digital pulse that is the digital signal 1, but you can change the duty cycle there, right? So for instance, you can have basically the pulse to be just up half of the time 5 and half of the time 0, but this happens quite quick, and it appears at the end that just half of the voltage of 5 is basically on it. Okay, so basically the duty cycle drives the voltage at the end that you can observe at the end, and you can use the analog write function for doing that. Yeah, so you get another pin, and you set the duty cycle, right? So 255 is full, so it's like a digital high. But if it's, for instance, 128, it's just half. 64 is just a quarter. 33 is just an eighth of the original voltage of 5 volt or 3.3 volt, depending on what you're working on. So this is how you can basically write the analog signals. And again, what you can do, for instance, is you can modulate the intensity of the light with it, just as an example to play with. Okay, and that's it. I think you have some resources for reading. So it's more about basically the seed starter kit. So there's a website you can see. We got also some examples here, which is in the sketchbook starter kit. This is actually the folder you copied, or some of you have copied, to play with. But also the Arduino website itself is also a good resource. Okay, thank you very much. Yeah.